everybody who is watching this video. My name is Olenjolai from beautiful, fantastic country that is located in East Africa called United Republic of Tanzania. I would like to welcome you into this official YouTube channel that called it Tanzania Online A-Level Secondary Schools or SECI Schools in square bracket OLENJOLAIM. That's our official channel. Simply, I would like just to remind you that the main visions of, the vision of this channel or the main goal of this channel is to teach students advanced science and also subjects in advanced science and also subjects in advanced mathematics. That's the main visions of this subject, of this channel. So in this channel, currently I will teach you 8 subjects. Okay, it means I will teach you advanced physics for the Form 5, advanced physics for the Form 6, advanced mathematics for the Form 5, advanced mathematics for the Form 6, and also I will teach you advanced chemistry for the Form 5 and advanced chemistry for the Form 6. Those are the 60 subjects. And then I will teach you basic applied mathematics for the Form 5 and basic applied mathematics for the Form 6. So total are 8 subjects. Regularly or obvious or usual in a particular schools, a physical schools, it means that those 8 subjects, they should be taught by the possibly 8 teachers. But fantastic enough, God has given me this responsibility. I will do the responsibility that is just like I will do myself at all of those responsibilities. It doesn't mean that I'm very exceptional compared to others, but that is how God has created it and asked me to do this program. So you'll find that this channel is for the senior students because I'm solving national problems. I experienced it myself when I was in advanced level, and even some of my classmates experienced the same situation, and even students who are doing the advanced studies right now, they experience the similar experience, similar challenge that to cover the advanced subject in science and mathematics is not an easy job. It's a tough job, and especially that if you have poor organized materials and don't have a good guidance, and then you find that you don't have, it means you don't know that where should you start, where should you continue, where should you end. You don't know it means you don't know the whole picture of how things are going. And it happens also that there are many reasons that make advanced students in nations to fail to understand the subject easily. There are many reasons. Some of them you find that maybe scarcity of teachers, or you find that possibly the teachers are there but are not playing their responsibilities. Or sometimes you find that maybe because it is expensive, for example, to own a book, a physics book, let's say in physics, one book, it can cost you 40,000. So not every Tanzanian can afford that. Okay, and in case if you got the, we call vacation training, that we call the tuition, you find also advanced training for the science and mathematics is expensive. I know because I did for 5 years. So I taught to students during the vacations and even during the evening sessions after the regular classes. So hopefully now this is the gift to the Tanzanian. I won't charge you any amount of money on getting these materials, you see. So God has anointed me, has given me his gift of teaching. So I want to offer the thanksgiving through the Tanzanians and Africans and even any students around the world, and any teacher around the world can benefit from these materials because they will be online, so you can access them anytime and at any day and any times and anywhere. So I would like to ask you that to make sure that you subscribe, because we'll be adding many videos in this channel, and also share the secret, share what you enjoy right now. Don't be selfish. Share with your colleagues, and then again tell us you are enjoying these materials from where, from which continent, right? And then from which country, from which city, from which region, from which high school. So tell us in the comment sections. Again, finally, before we start the session, which is lecture or session 17 of general chemistry, in case you have questions, please use the comment section. First of all, read the descriptions of the video that show more. You'll get too much information. In case also you want to ask questions, you want to ask me questions, or you want to ask other students questions, use the comment section where you will meet or you have even online group discussion with some other special and serious students around the nations or around the world. So use that comment section to ask your questions, any questions that you can ask there, and you will find that you will get help. I will come even myself on the comment sections and answer your questions. I'm trying also to develop some other platforms of interacting with the students, but currently you can use the comment sections of every video and ask the questions regarding about what you've been learning. Again, because this is I say that it's my gift, is my offering to God, that I offer this material free. I could even charge a lot of money because they're very expensive. They are very expensive. Everything's expensive here. Just preparing the sessions and even having the digital devices of high definitions is very expensive. I spend a lot of money, and even God didn't give me freedoms to tell you what the initial budget for this program. However, that the initial budget, okay, it has been met, and even there are scarcity of some of the digital devices, but there is a running cost. So in case you feel from your heart that you want to offer God your sense-giving offering from your heart, it's free, any amount, but you offer it faithful, then you can send it through this mobile number, +2557597457331, and the registered name is Olenjolai. That is my name. So I think that you have, make sure that also you go through other videos. For example, this is lecture 17. It means there are some other lectures. You have to make sure that you go through them before coming, because this course, I prepared the lectures sequentially. It means that from top to bottom. So make sure that you go through them. Okay. So then the issue today, I will just do the quick review of what I taught you in lecture 16. In lecture 16, I began with the title called the drawing or writing advanced, so we call it advanced electronic configuration. Writing or drawing advanced electronic configuration. And then we say we have two methods in chemistry. We have a method we call the orbital method, and I told you that we use this to write electronic configuration where electrons is distributed. We call it the distribution method. And then I told you that we can use the box method, right, to write also electronic configuration. Our orbital method, this is not distribution, but no, orbital method is not distribution method. It's the box method, which is we call distribution, because to provide distribution support of electrons. And then again, I told you that, okay, we did some examples, and then we see the challenge is whether by writing by using orbital methods or box method, we find that if the atomic number of an element, or if an atom, for example, barium, consists of 56 electrons, to write the electron configuration by using orbital method and box method, yes, we can manage, but we have a longest or a very long electronic sequence, electronic configuration sequence. So I told you that now the alternative, the chemistry didn't there, then they found that some of the inertia contains electrons which are complete shells, and this we found out noble gases. So I told you 7 noble gases that we can use them to write electronic configuration. For example, helium, for example, neon, for example, argon, for example, kryptons, xenon, radon, etc. So in case that you want to get too much details, because we ended there, make sure that you go to the lecture 16 before you come to the lecture 17. So let us go to the today's subject. So in this session, I will teach you, I will add up, I will build it on top of what I have taught you in lecture 16. And today, we are going to take a focus on the shell of an atom. Remember that an atom has a nucleus where the mass of the atom is concentrated and also has a shell. Okay, and then the whole discussions of this lecture, we are discussing about shells of 40 of the atom. So today's lecture is titled as Valence. You know, you learned valence in Form 2. Valence and core electron. Valence electrons. So this is called the valence electrons. Teach about valence electrons and the are core electrons. And the core electrons. Valence electrons and core electrons. So, let us define and then see the secret within it. Okay, so you say that by definition, a fundamental question, what is valence electron? Right? What is valence electron? What is valence electron? What is valence electrons? So valence electrons is a singular or plural. Okay? Many of them are plural, valence electrons. Okay? So valence electrons are the electrons found, or as electrons filled or found in the valence shell. Say valence shell. So this valence shell, we call it, or in other words, we call it outermost shell. Outermost shell. So outermost shell. This is how we call it in other words. So that the meaning of 40 of valence electrons. So valence electrons, these are what electrons filled or found in the valence shell. Again, I want just to tell you that what the meanings of valence shell, right? So the shells in which valence electrons are found is called valence shell. Before I draw it from there, what you know from your form 2, what is valence? What is valence shell? Valence shell, right? What is valence shell? Okay, electron falls in the valence shell. This is E, excuse me, C then E, valence shell. So we say that valence shell. So we can say that just a valence shell. We say that if the shell is the outermost shell, right? Outermost shell of 40 of an atom, right? Whereby the valence electrons are filled. Valence electrons are filled in. Okay? That the means of 40 of Valency shell. So for example, let me just begin with a simple example that you are familiar. For example, if we draw that example, the electronic structure, because this is not a new song for you, the electronic structure of what? Of, let's say, let us take a simple element, that's sodium. And symbol sodium is capital N, then small n. So sodium is an element, is the 11th element in periodic table of, in any periodic table, whether it is a periodic table of 20 elements or more than 20 elements. So the electronic configurations of sodium, we used to write that in a form, during the form 2, we say that it contains 11th electrons has 2 ratio 8, then ratio 1, right? You remember that concept. I want to remind you, because always I want to build from the foundation that you have. And then the electronic configuration, so according to this electronic configuration, this and this means this and this, because this is first shell, second shell, third shell. So this is first shell, this is second shell of sodium, this is third shell. So what happened there? So it means that the first shell and second shells, these are the inner shells, and this is the outermost shell. It contains only 1 electron. So if we draw it as a structure, according to the form 2, the structure of sodium atom, this is the nucleus. Say nucleus. So this is the nucleus. And then you have the first inner shell. Because we say the title is one of the concepts we are covering is in lecture 17, valence electrons and what we call electrons. So that's the nucleus. And then we come to another we call it another inner shell. Then you have what? The outermost shell. You have to draw good drawing tools. So we say that, we used to say that here we used to fill electrons like this, contains 2 electrons, and then this one contains 8 electrons, right? 8 electrons, 4, 5, 6, 7, 8, right? And then this the outermost shell. So we used to say that, and if you didn't learn about this, I'm teaching you right now, these 2 shells, we call them inner shell. So the inner shell carries what? Inner shells carry what? Are core electrons. I will come later there. Okay? And then this one, we call it in chemistry Valency shell. Say Valency shell. Okay? Valency shell. That is the names of that shell. And then the valence electrons now, this is called what? Valence electron. It may remind you and build the foundations on what you need. Valence electrons. And then this one, so valence electrons is singular. And this now, including this we call them inner electron. Inner electrons, we call them co-electrons soon. Okay? So that's what we taught you during the Form 2. And even myself also, I'm teaching chemistry for the Form 2 in my another YouTube channel titled as Tanzania Online O-Level Circuit Schools Olenjolai M. So you can search in YouTube, searching, and you'll find a lot of materials of chemistry from Form 1 to Form 4, physics Form 1 to Form 4, and the mathematics Form 1 to Form 4, and even that soon you'll find the materials of additional mathematics Form 1 to Form 4. Okay, so that is what we used to learn during what? During our O-level studies. So this is the foundation or the fundamental concept that we have. So in advanced electronic configuration, we say that, for example, if you write electronic configurations of sodium, right? Write electronic configurations of sodium by using orbital meson. I told you that for this case, according to the alphabet principle, we have the first shell is 1s with 2 electrons, and then the second shell is 2s with 2 electrons, then the third shell is 2p with 6, because these are with 6 electrons, right? And then the next one is 3s with 1 electron. So from this electronic configuration, what do we find? We find that these sub-energy levels, these series sub-energy levels, they form, sub-energy levels, we find them on the first and second, first and second shell. So for example, let me just link it from what I told you there. So this is the advanced electronic configuration, right? You see in this point, this is the first shell. So the first shell, this is the first shell. So this we call the first shell. And this is what? Second shell. And this what? This is second, or electrons in the third shells, right? Or in the outermost shell. Similarly here, this we call the first shell. The first shell. And then we say that this means these 2 sub-energy levels, S and P orbital, and S and P sub-energy levels, representing what? The second shell of what? Of an atom. And then this one, 3s1, representing what? The third shell, and because it's outside, so this is what you call the valence shell. So these 2 shells, we call them in chemistry what? Inner shell. Okay, inner shell. And the electrons that we have here, we call them inner electrons. So all of this one, we call them inner electrons. So these are inner electrons. I want you to understand. And this is what we call the valence electrons. You see, chemistry is beautiful, and especially general chemistry is beautiful. So you see the relationship between the fundamental concept that you have and what we are trying to teach you in advanced level. Okay, so that's the case for the valence electrons, valence shell. I believe that you know that. So you can identify. So what does it mean? It means, for example, we say that in sodium there, in advanced things, means that from what? From the electronic configurations of sodium, result including maybe neon. We can include our what? Neon, our noble gas, right? So we say that neons, and then here we have what? 3, we have what? 3s, 3s power 1. So it means that neon contains 10 electrons. So this means that it is what? It's showing what? So here we find inner what? In electrons. Okay? In electrons. So it means that all the electrons filled in the normal gases, this we call them inner shells, and also we call them inner what? Electrons. And hence, all the electrons that we find away from the noble gases, it means that outside of the noble gases, this we call them valence shell, and they carry what? Valence electrons. Right? Do you understand the beauty of chemistry? Valence electrons. So from the electronic configuration, we don't need again to draw this structure. This is fundamental structure. So you can write the electronic configurations of an atom, advanced electronic configuration, and we get all the information. Because here, you find that in the noble gases, we have inner electrons, or co-electrons, so we call them co-electrons too. And then, here we have what? Valence shells. So this is the valence electrons. Valence shell carry what? Valence electrons in an atom. So all the sub-energy levels that will be away, or will be next after the noble gases, we call them Valency shells, and they contain valence electrons. This concept is very important because in the next, I think soon I will teach you about the electronic configurations of of ions. And then so you find if this sodium ionized by losing 1 electron, it doesn't lose electrons in this energy level. It will come and lose electrons in the valency shell. Because if sodium is ionized, they have sodium positive 1, so we'll discuss about that soon. Okay, good. In case you have questions, don't hesitate to ask in the comment section. Again, after building that foundations on that concept, I would like also to now to take some few minutes to teach you about core shells. Core shells, we call them core shells. Okay, core shells, and core electrons. Okay, so the fundamental question is, what is core shell? So this is very important for the next session, for the next lecture 18. What is core shell? Okay, because there we have core electrons. You have to understand shell, which is the house of the electrons. So you say that the core shell is a inner shell, right? Is the inner shell. So for example, core shells, if we say that in plural, is the inner shell, okay, formed, or is the inner shell contains what? Contains inner electrons. Contain inner electrons. Contains inner electrons. So for example, the core shells, these noble gases are the core shells. So these are the core shells. Contains what? Inner electrons. The core shells also, we call them in other names as what? Call them inner shells of an atom. Fantastic. So if that's the case now, let us accelerate the concepts. Okay. So if that's the case now we have again another fundamental question. What are the core electrons? Because in the questions maybe you can ask anything else about core electrons. What are the core electrons? So core electrons, you say that as electrons, filled by, or the electrons contain what? These are the electrons are filled to the inner shells of what? Of an atom. Sometimes we call them what? Inner electrons. Good. case. If that's the case, then we say fine, understood. We say an inner shell's electron configuration corresponds to the one of the noble gases in the noble gas core. The shells in which valence, okay, so we say, okay, yeah, that's, say the noble gas core to, okay, so we say that, yeah, so we say for a total tens of what we call electrons. So for example, okay, in the electronic configuration of what? Of sodium, right? Which we wrote in two forms. We wrote in shortened hands, and we wrote in the longest hands. So we wrote like this one. So this is the longest orbital method. Okay? And then you have 2p, you have 6 electrons, then you have 3 3s power 1. So if you write in this way, we can identify easily the number of electrons. So I told you that this is the first shell, and this is the second shell, and this is the third shell, which is the valence shell. So if that's the case now, we say that, well, good enough. So for example here, we have 2 inner shells. So there are 2 inner shells. This is the piece of information. Inner shells. Inner, or we call them core shells. Right? Again, so this is 1. Again, we say that from that electron configuration, there is only one valence shell. Only one valence shell. This one. Okay? And then another piece of information said that the 2 inner shell, the 2 core shells contains what? How many electrons? 2 plus 2 plus 6, 10 electrons. So contains 10 what? 10 core electrons. 10 core electrons. 10 core electrons. Again, the first piece of information, we say that the valence shell contains how many electrons? Contains only, so this is deeper electron configuration, only 1 electron. Contain only 1 electron. Fantastic. Beautiful. Chemistry is beautiful, my beloved student. So, if that's the case now, we say that, well enough, this is beautiful, fantastic. So we say that, good. Okay. So we analyzed it, and I believe that now we have understood almost everything concerning about valence electrons and core electrons. In terms of the noble gases, for example, that now I want to relate, if you write the electron configurations by using the noble gas, the corresponding noble gas is ranging from 2 to greater than the atomic the number of electrons should be greater than 2 and less than 10, which is what? Neon. Okay? And then the next subenergy level is 3s power. So in this one, we say that, another concept that I want to share with you, we say that an inner shell electrons configuration corresponding to one of the noble gases known as noble gas core. So there's this sentence, an inner shell. From this electron configuration, an inner shell of what? An inner shell of any atom, not only sodium. I took sodium as an example. Of any atom corresponding to one of the noble gas. To one of the noble gas, right? To one of the noble gas, to one of the noble gases, to one of the noble to one of the noble gases, so plural noble gases, okay, noble gases, and this one we know also the inner shell is known as, we call it is known as what? Is known as what? Ask yourself, noble core. So we call it core shell or noble core. We call it noble gas core. Noble gas core. Fantastic. So in the exam, you might find a question ask you that define noble gas core, or write short notes to explain briefly the meanings of noble gas core. So it won't be a shock because I've told you before the exam, because this is the exercise. We are doing the exercise. We are doing the practice before the match. The match we have the half fine, we have the, you know, the round first, and then we have the final, we have the half final, we have quarter final, we have half final, and then we have the final, which is the final exam, which is next exam, advanced certificate, secondary education exam. But that is not the final exam. That is just in case of writing and experimenting. But the final, beautiful, and the no time limited is what is solving a real life problems in your community and in your nation. So this is about what? So it's an inner shell of any atom, okay, atom corresponding to one of the noble gases, and this inner, and in other words, you say that noble gases. So I think that here sentence is not clear. Noble gases, I should end this sentence, and then you say that the core shells, or the core shell is also known as what? This is also known as noble gas core. So that's another name. So for example, in case of sodium, we find that the inner shell, example, in electron configurations of sodium, by using the noble gases, we find that the inner shell is neon, and then you have 3s squared. So what do we find there? We find the inner shell, the inner shells of 40 of sodium corresponds to what? Correspond to neon noble gas. Correspond to neon noble gas. Okay, so that's the point I wanted to make. I believe that you understood. So you can take any element, you can learn its core shell, you can learn its core element, electrons, you can learn its valence electrons, you can learn its corresponding noble gas, you can learn the noble gas core, you can learn about you know, that even the valence electrons you can know, you can identify. And this is very important concept. Okay? So if that's the case now, I have an example. Okay? I have an example that I want to present, and I want just to teach you. And this is example. Okay, one of the example. State that write the electronic configuration. Say electronic configuration. Write the electronic configuration. Write the electronic configuration of elements with the following atomic numbers. Let's see those atomic numbers. So there are four. So I'll write 2 and then leave others at the homework for you. first one, the element that have atomic number of 13, means number of electrons are 13. And then an element which is containing 27 electrons. Again, you have other one, an element that's containing 9 electrons. So this is your homework. You write yourself. And then the first one, which is simplest also, write the electron configuration of an element which contains 25 electrons. So that is, so also this is the homework. Try it, write, enjoy it, the beauty of it, try your level best. Okay? So then, and then the method is not recommended. The method is not stated whether it is orbital method or whether it's orbital method or you are going to use what box method. But the favorite one is, in case you'll be given a freedom to choice, the best one always is a box method, because you'll see electronic distribution. If you enjoy this lecture, please tell me in the comment section, please. I want to understand that you enjoy and understand and ask me the questions as well as we can. And I'm happy to teach you and to be a part of your learning process in advanced level. So solution. So solution, we say that first of you can use the periodic table, the list of elements in the periodic table, as I showed you. And this is the best one. We call the modern periodic table, which contains this number of electrons. You see that this is the top, so I'm moving from bottom to the top, and then those are the electrons. And so you find that what do you see here? You have too much information. The superscript, these numbers above, representing the number 40 of electrons, not the atomic mass. Present the number of electrons. This is first group, second group. These are the transition elements. These are the other groups. These are noble gases. This is, we call them halogens, and these are the other elements. So you find, for example, we can identify there an atom which have 13 electrons. You know that it's aluminium, right? And then an atom which have 27 electrons. 27 electrons, we check this one is cobalt. Interesting. Then an atom which have 9 electrons, we find it is fluorine. And then an atom which have 25 electrons, its name is 25, so its name is manganese. So you enjoy the beauty of chemistry at your home. So you say that we have to write the electron configuration. So we say will be following steps. The first step, we know the number of electrons, no need to identify the number of electrons. So the first step, we say that let us use the box method, right? Okay, so you can use the box method, or you can use, because here you are not limited, you can use either of the method which is simple for you, right? So first step, let's say by using what? By using the box method, right? The box method. So by using the box method, then what we say? We say that an atom which have 13 electrons, this is aluminium. Its electron configurations of aluminium, by using the box method, we say that it contains 1s, right? 1s orbital, subenergy level, and then, so here we have its box, how many electrons can occupy? 2 electrons, that the first inner shell, or first core shells, and then you have 2s square, second sublevel, but in second shell. Here we have how many electrons? 2 electrons. Again we have 2p, and then it is full with 6 electrons. The p orbital contains what? The p subenergy level contains 3 orbital, px and py. So then here we have pair of electrons, here we have pair of electrons, here we have pair of electrons. And then we say that this is all correspond to the neon noble gas. Then we have 3s containing 2 electrons. So I think that, let me, because of the space, write it here. So you have 2s and then 3s. The 3s can accommodate only 2 electrons. So then we say that here we have 2 electrons. So remember how many are these? 10. So plus 2, 12. And what the atomic number of, or the number of electrons in aluminum? 13. So we still have 1. So the next sub-level is what is 3p. And the 3p will occupy only 1 electrons because the aluminum still containing 1 electrons. So what do you say? So we have this case, we have here. So this is the point, or this is the orbit which contains the 1 electrons. So that is 3p per 1. So what do you learn from here? So if you write the electron configuration by using the orbital method of aluminum, so second state, if you use it, it means that write what? Electron configuration. Electronic configuration, right? Electronic configuration by using what? By using orbital method. So if you be using orbital method, what will we find? So you'll find that, for example, for this case, we have 2 alternatives. We have brought the longest, because this will be the longest electron configuration, but we can shorten it with the noble gas called neon, right? And then we have 3s square, then we have 3p per 1. So these are valence sublevels, or valence shell, contains 3 electrons, and it is true from the previous. Similarly here, this is valence shell, 1 valence shell. And these are 2 inner shells. And here you have 2 inner shells corresponding to the neon noble gas. So then that's the answer. So either you use the box method or you use the orbital method, the answer will be the same and you'll be right. So if that's the case, now we go for what? We go for Roman 2. Roman 2, we found from the, we say that the name, the first state, we say that I use the periodic table, knowledge, whether knowledge or whether you have used a periodic table to know or to identify the element that contains we say how many electrons? 27 electrons, right? 27 electrons. So from there, a modern periodic table, we say that the element, okay, in previous demonstration, the element is what? Cobalt. Say cobalt. And this cobalt symbol is this. So, how many electrons are there? 27, right? So we can use either the orbital method or the box method. Let us simplify life and use the orbital method. This is cobalt. So if it's 25, it means that the corresponding noble gas will be ranging, will have the number, will contain electrons, can contain electrons greater than 18, but less than 36. And that is what? Less than what is 36, that is what? Argon, right? So it means that here we can start with a noble gas, which is argon. Argon contains how many electrons? It contains 18 electrons. So it can occupy 18 electrons. So 27 minus 18, what do you have? 27 minus 18 will remain with 9, because 9 plus 18, you get 27. So these 9 electrons now, look the way that we are going to do. The next subshell, the next energy level, remember that. The helium occupies 2s. Remember that, let me just remind you. Helium, the next sub-level after helium is 2s. And then the next, let me just summarize it here. So we say the second state. identify the corresponding one. So the second step, identify the corresponding what? Corresponding noble gas of what? Of cobalt. Not carbon monoxide, this is cobalt. It's an element of cobalt. So the corresponding is what we say that it is what? It is argon. Right? So because it is argon, what do we say if it's argon? We have to know also the next sublevel. So in the previous column we wrote that the electron configurations of cobalt, this one should start with the noble gas called the argon, and the argon accommodates only electrons, 18 electrons, and then we still have 9 electrons which should be filled in the valence the valency shell. So then the protocol means that the concept, I'd like just to remind you, remember that this concept I told you in lecture, the concept that I told you in lecture 16. I told you this concept that the helium, okay, the sub-energy level after helium is 2s always. The sub-energy level after neon, and we saw it in sodium, it is 3s. Depends the number of electrons that contain. The next sub-energy level after what? Argon, say argon, is what? 4s. So it increases by 1 principal quantum number, right? 4s. So again, the next we say that the next sub-energy level after krypton, it is 5s. The next sub-energy level after xenon, say xenon, this is what is 60s. And then the next after radon, okay, it will be 70s.